Hello friends, welcome to this lecture, Shear Force and Bending Moment. Myself, Mr. Y.S. Patil, Department of Civil Engineering, Sharad Institute of Technology, College of Engineering, Yatra. In this lecture, we studied about types of beam, shear force and bending moment, sign conventions and one numerical. So first of all, types of beam. Basically, types of beam depends upon types of supports or number of supports. So first one is a cantilever. Cantilever means one end fixed and other end free. Then for cantilever beam number of reactions is 3, means for that fixed support the number of reaction is 3. Second one is simply supported. Simply supported means just resting on two supports. Support may be hinge or roller or simple support. Then third one is overhanging. Overhanging beam means some part of the beam is extended from that support. This is the both side overhang beam. Continuous beam. For continuous beam, the number of support is more than 2. Means in this beam, the 4 number of supports and 3 span, means 3 span 4 support continuous beam. The next one is fixed beam. Fixed beam means both ends are fixed. And last one, that is cantilever simply supported, means or the proper cantilever beam. Proper cantilever means one end fixed and other end or that far end is simply supported. So basically shear force and bending moment. Shear force and bending moment is required for design of beam. Means by using that shear force and bending moment we can provide steel in the tension side or in compression side, and for that using that shear force we can provide shear reinforcement in the beam. So let us see what is meant by shear force. Shear force at any cross section of the beam is the algebraic sum of all vertical forces on the beam acting on the right or left side of the section. Means it is simply the algebraic sum of the all forces right side or left side of any section of acting on the beam. Sign conventions for shear force is, this is the most important sign conventions. This is a section XX. The sign conventions for shear force, right side of this section, upward force consider negative and downward force consider positive. Once again I repeat, for right side upward force consider negative, downward force consider positive, and for that left side upward consider positive and downward consider negative. This is the sign conventions for shear force. Then next, bending moment. Bending moment means bending moment at any cross section of the beam is the algebraic sum of all moments of all forces acting on the right or left side of a section. Means bending moment of any point is equal to the algebraic sum of all moments of section either right or left side. Means there is bending moment for that particular point. So sign conventions for bending moment is, this is the X section, this is the right side. Anti-clockwise moment is positive for right side and clockwise moment is minus or negative. And for that left side, clockwise moment positive and anti-clockwise moment negative. This is the most important thing, sign conventions. Once again I repeat, the right side and anti-clockwise positive, clockwise negative, and for left side clockwise positive and anti-clockwise negative. Let us see one small numerical. Draw a SFD and BMD for a given beam. A simply supported beam having 2 point loads, A and B is a support and C and D is a point load, that is at point C 15 kN and at point D 10 kN. That AC distance is 1.5 meter, AD distance is 3.5 meter and AB, the span of the beam, is 5 meter. So let us see how to draw SFD and BMD. First of all, we want to calculate reactions RA and RB. First, consider summation Fy is equal to 0. upward force is equal to downward forces. In this system, total 4 number of forces is there, RA and RB going in upward direction and 15 and 10 kilonewton going in a downward direction. So RA and RB plot one side and 15 and 10 kilonewton plot another side. So RA plus RB is equal to 15 plus 10 is equal to 25 kilonewton. This is RA plus RB is equal to 25 kilonewton. Then next, take summation M is equal to 0. Taking moment about A. I want to taking moment about A. So number of forces, now RA becomes 0 because the line of action of RA and point A which coincide with each other. So number of forces that due to this 15 kilonewton with respect to A, moment is clockwise. For this 10 kilonewton, moment is clockwise, and for this RB, moment is anti-clockwise. So this 15 kilonewton and 10 kilonewton plot one side and this RB plot another side. So 15, this is a force into perpendicular distance from point A is 1.5 meter. 15 into 1.5 plus next is a 10 kilonewton force and the perpendicular distance from point A is a 3.5. So 10 into 3.5 plot on the same side is equal to, now RB direction of the moment is anti-clockwise and the distance is total is 5 meters. So RB into 5. So simplifying this equation, we got RB is equal to 11.5 kilonewton. And we know the relation between RA and RB. RA plus RB is equal to 25. Put up this RB value in this equation and we got RA is equal to 13.5 kilonewton. This is the first step to solve this problem. First calculate reaction RA and RB. Now RB becomes 11.5 kilonewton and RA becomes 13.5 kilonewton. Then next calculate SF calculation. So shear force calculation. First, before starting shear force calculation, we know the sign convention. Once again, already discussed sign convention. Consider now only right side. And for right side, upward force negative and downward force positive. For shear force calculation, we just consider only right side because it is simple to memorize or it is simple to solve the problem. So starting from B, and shear force for each point having two shear force values, that is right side and left side. So for every point we want to calculate two values, that is B right and B left, D right, D left, C right, C left, A right, A left. So starting from right side point, first point is a B and that is BR. So assume this section mark a section. Now number of forces on the right side of this section is 0. So shear force at BR is equal to 0. Then next, this section move just left side of this B and consider right side of this B. So number of forces on the right side of this section is 1, that is RB, and RB value is 11.5 kilonewton and the direction is upward. So upward force right side minus. So put up minus 11.5 kilonewton. Then next section, consider just right side of this D. This is now DR. Then this section, consider right side of this section. Total number of forces is only 1, that is 11.5 kilonewton. So number of forces 1 and the direction of the force is upward. So minus 11.5 kilonewton dr. Then next consider DL, means just left side of D, and once again consider right side of this section. So number of forces on the right side of this section is 10 kilonewton and RB. So RB going upward minus 10 kilonewton going downward plus. So minus 11.5 plus 10 is equal to minus 1.5 kilonewton. Then next, similarly, you consider section on just C right. Number of forces on the right side of the section is once again two forces RB and 10. So remain as it is this calculation, minus 11.5 plus 10 is equal to minus 1.5 kilonewton. Then next consider C left and once again right side consider. So total number of forces on the right side of this section is RB 10 kilonewton and 15 kilonewton. So RB value is minus 11.5 because force going in a upward direction, and 10 and 15 positive because they are going in a downward direction. So minus 11.5 plus 10 plus 15 is equal to 13.5 kilonewton. Then next consider AR and once again consider right side of the section. So number of forces on the right side is 1, 2, 3. As good as that CL. So minus 11.5 plus 10 plus 15 is equal to plus 13.5 kilonewton. And once again consider left side of the section, consider right side of the section. Total number of forces now 4, RB, 10, 15 and RA. So the value become 0. So one checkpoint is here. We starting from 0 with end is 0. If this is if your answer, all answers are correct, it will become like this. Means start with 0, end with 0. Now by using these all values, you can draw the SFD. Positive value, this is the baseline. Positive value plot upside of this baseline, negative value plot downside of this baseline. So first BR is equal to 0, 0. BL is equal to minus 11.5. Means from this point to plot 11.5 downward side. Now you not required put up minus 11.5 because already minus sign plotting on the downside. So you just write 11.5. Then DR is 11.5. Means once again D is a point, DR is 11.5. Then DL is minus 1.5. Means you want to move plot 1.5 from this baseline. Then CR also minus 1.5. So from this point plot 1.5. Then CL is 13.5 and now is a positive. So plot upward side. So from this point plot 13.5. AR 13.5 and AL is a 0. Join all points by sequential, and this is your SFD for beam. Then next BM calculations. For BM calculation, this is the sign conventions. Right side anti-clockwise moment positive, clockwise moment negative. Left side clockwise moment positive, anti-clockwise moment negative. So bending moment calculations. Bending moment at A and B is equal to 0 because this is a simply supported ends. That's why A and B, MA and MB will be 0. You just require to calculate bending moment at C and bending moment at D. So first calculate bending moment at C. When you calculate bending moment, you just consider section exact on the C. In last shear force, we consider right or left of the C. Now, but when you calculate bending moment, you should draw section exact on point C. So, due to that section, the beam split up into two parts, right of the C and left of the C. In right of the C, there is a two forces, that is 10 kilonewton and RB. And on the left side of the section is only one force. So minimum number of forces on the left side. So consider left side of the section of point C. So number of force is 13.5 kilonewton. With respect to C, what is the direction of the movement is clockwise and left side clockwise movement is positive. So force is RA, that is 13.5 kilonewton, and perpendicular distance from point C is 1.5. So bending moment at C is equal to 13.5 multiplied by 1.5. So calculation of this is 20.25 kilonewton meter. This is the bending moment at C. Now I want to calculate bending moment at D. So consider section exact on point D. Now, due to this section, the beam split into two parts, right and left. On the right side, number of force is RB1, and on the left side, number of forces is 2, that is 15 kilonewton, and this RA 13.5 kilonewton. So consider minimum number of forces side. So minimum forces on the right side of the section. So RB, it is a force that is 11.5, and from point D, RB distance will be 1.5, means this is the 3.5 and total span is 5. So 5 minus 3.5 is a 1.5. This distance is 1.5 meter. So force 11.5 and distance 1.5. The direction of the moment with respect to D is anti-clockwise, and we know the anti-clockwise moment right side consider positive. So 11.5 into 1.5 is equal to 17.25 kilonewton meter. This is the bending moment value. Now by using this bending moment value, we can draw the BMD. So first, bending moment at A and B is equal to 0. So A point and B point is 0. This is the baseline. Whatever the positive value plot upside, whatever the negative value plot downside of this baseline. So next, bending moment at C is 20.25 kilonewton meter, and this value is positive. So plot upside of this side baseline, that 20.25 kilonewton meter. Then next, bending moment at D is 17.25 kilonewton meter. So plot, and this is a positive value, so plot upside of this baseline, that is 17.25 kilonewton, and join these all points using straight line. And this is the final BMD of this problem. And these all values are above the baseline, so BMD is positive. This is a simple problem to draw SFD and BMD. In next lecture, we studied about draw SFD and BMD by using UDL. Thank you.